Well, you probably noticed in the background here we had the flow bench set up. Tell us a little bit about this. You were talking again earlier that this is just a tool to measure what you've done by porting.
Yes. I guess it may be a fairly common misconception. A lot of people will call and say they want to get their heads flowed, and what they really mean is they want to get their heads ported. What the flow bench does is it takes a measurement of the airflow through the head. Basically what you do is you put your valves in the head with some lightweight springs so they're easy to open and close. And to check out the intake port, and different guys will do this differently, but I always use a manifold and a velocity stack on the manifold so that you're not just measuring the entry to the manifold, but you're getting a smooth entry through the manifold.
Okay.
So when we take a flow test on the intake, we'll open the valve up and take this test at different valve lifts. Generally up to and past the lift of the cam that's going to be used. Kind of a standard is on most street heads, I'll check them every 50 thousandths up to 650 lift. That'd be 650 thousandths lift. What the machine does, it's basically two large heavy-duty 220 volt vacuum cleaning motors, and when you're on the intake it will suck air into the intake track down through the cylinder, and it'll, this being all computerized, it'll give a direct reading of the CFM on the computer screen, and it will actually sample it and record it. This is a little kind of a step up from the old type where you had to take your readings off the manometers and then you had to go through with the calculator afterwards and calculate your CFM. Another thing to be aware of on flow testing is these machines are capable of taking the flow test at different pressures, test pressures. Many of the motorcycle shops with the smaller machines will take their pressure or use a 10-inch test pressure. Many will use a 25-inch test pressure if they have a bigger machine like this. The standard of the industry for automotive use is 28 inches. So you have to be kind of always have that in the back of your mind when you start comparing readings. Because you can convert those from different test pressures, but if you can't look at them directly at 25 versus 28, it won't really be a fair comparison. But like I say, you can convert the figures from 10 inches to 28 inches and get a good comparison. So basically, like I say, we have the valve open. We're going to draw air through the system. When you check your exhaust side, you're going to, of course, close your intake valve, open the exhaust valve, and it'll actually push the air up through the cylinder, through the head, and out the exhaust port. Okay. And it's, over the years, it's proven to be one of the the biggest tools available for increasing power in an engine, because the more air in, more air out, more power. Okay. And it's, while it doesn't exactly simulate what's happening in an engine, it's close enough that you can count on the fact that if you get a big increase on your intake flow, you're probably going to get a fairly substantial increase in your horsepower output, assuming that you didn't make other mistakes along the way. Would you like me to start the machine?
Yeah, please do.
It makes a lot of noise, so
right.
Nothing else you get to hear what a flow test sounds like. I've got this valve already opened up. I'm already on the right range and stuff on my computer. Okay. So if I turn
That is loud.
Yeah. Normally I wear some mufflers on my ears when I when I do that. But
Okay, so I don't know how well the audio picked up. You were saying it shows you the test pressure up there,
right,
which gets into about the 28 range.
yeah. The computer is actually bringing it up to that test pressure, and it will. It won't actually come to the exact 28, which if you're reading it off the meter over here,
Okay.
you may think you're at an exact 28, but that manometer is always moving a little bit.
Okay, sure.
It actually shows up on here, but the
Okay.
computer is bringing it up and down to try and maintain that 28 inches, which doesn't really matter too much because once you're close, the computer is actually going to convert that. If it's 27.95, it will convert it, correct it rather
Okay.
to the actual 28 inches. So it's pretty
Okay.
accurate.
Okay.
And then, like I said, it gives the direct flow reading right off of here and records it. And it'll give a nice printout of more information than most people will ever have use for.
Wow. That's pretty cool. And then the exhaust side just basically works in the same manner.
Same thing, except you're pushing the air out.
So ultimately what you're trying to do is get the flow between the two of them as close to each other as possible, so it flows smoothly, or do you want more restriction on one side of the head than on the other?
Generally, there's actually some disagreement on that matter, and it kind of depends on the application. There are a lot of guys that will tell you that 70%, if your exhaust flow is 70% of the intake, that's plenty good. There are applications such as racing, especially if you're running like nitromethane or something like that, where you want it close to 100%, because the nitromethane actually carries its own oxygen. So you have, it's easier to get it in than it is to get it out.
Okay.
But so different applications. But generally speaking, if you can increase the flow on both sides without increasing the size too much, you're pretty much bound to hit a home run and increase the horsepower.
All right, now here we have some examples of, these are twin cam heads?
Those are twin cam heads. On the right here we have a completely stock head. The guides have already been taken out because they are going to be ported eventually when I find time. You can see they're actually fairly smooth port. Nothing like the old shovel heads where it was real obvious what that the port cores were pretty rough the way they were put in. However, there's a lot of room for improvement. Now the one on the left is actually this kind of old technology. This is something I ported probably 7 or 8 years ago. These actually had been run. They made over 120 horse on a 95 cubic inch with a fairly mild cam. They had a bigger intake valve put in, and other than that, you might want to look at the difference in the exhaust port. This would have started out as basically the same. Let's see.
That'll work. Excellent.
They started out as basically the same exhaust port. You can see the roof and the sides of the ported head have been changed quite a bit. The early twin cams had a very small exhaust port, which from my standpoint as doing porting was a good thing because it left a lot of material to work with. It's much easier to take material out than it is to add material.
Right.
Well, I've been, I guess I'm kind of weird, but being into knuckleheads, that kind of leads into working on obsolete stuff. So I've actually been doing more and more work recently, and most of it's been unpaid work on trying to get a little more performance out of shovel heads. This one is not actually belongs to the guy next door, but we're doing some work on this. Oversized valves. I've found that I can get the type of flow I can get out of these right now exceeds what the manifold is capable of flowing. And these heads will actually outflow the heads we used on a shovel head drag bike that was back in, I believe, 1990. It was the world's first pro stock Harley to run under 6 seconds in the 8th mile. And these are street heads. So that's the benefit of a flow bench is we're still learning stuff. Probably the guy that ported those heads back then, he's probably doing better work now too, because he's had another 15 years or better to sharpen his game. But I think there's more potential in these shovel heads than we've gotten to yet. I've also been working on some modifications with a knucklehead. And this is a set of knuckleheads kind of using as prototypes. But one of the big popular modifications way back when on a knucklehead was to put bigger intake valves in. And usually what this consisted of was finding a tractor valve and shortening it to fit. And that was probably, that was high technology for back then. The trouble with that is the tractor valves usually aren't in real good shape for good flow. The other thing is, when you start getting a real big valve head, it tends to get pretty heavy. And so I've been kind of working on this project for a year or so to get some smaller stem valves to fit in a knucklehead. And the first step was to come up with some valve guides for a 5/16 stem. Stock knucklehead is a 3/8 valve stem size, and I had a couple hundred of these made, and I offer them both in a stock style, which has got the big top like this, and also set up for a valve guide seal, which is kind of a nice touch on a motor that's over 60 years old. But by going to a 5/16 stem, we can keep the weight of the valve down a little bit. We can get a modern profile on the back of that valve. Like I say, I've had a couple hundred of these guides made up. This is the prototype valve, and I will eventually have a bunch of these valves made, also offered for sale. Right now it's pretty easy to do a swap. If you put new seats in, I've already got 2-inch valves that'll work. This one is a 2.060, which is about as big as you're going to fit in a knucklehead in normal use. And of course, the bigger valve, especially on a knucklehead, which has a pretty archaic shape to the port, put it that way. The bigger the valve, the better, because you're not going to get a good approach to that valve. The intake track on a knucklehead kind of goes like this. You're coming in the carburetor like this, then you're making a left-hand turn, and then you make another left-hand turn, and then you have to turn down into the valve. So that's a lot of twists and turns. And because of that, you're not really ever getting a straight shot at that valve. So the bigger the diameter of that valve, the better chance you have of getting a decent amount of air in there. So like I say, it's a little strange to be coming up with new performance product for a motor they haven't built since 1947, but that's just the kind of guy I am.
How does this compare?